myopia. Near distance we can see, far distance we can see. Myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, 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 myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, hypermetropia. For that correction we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, convex lens, hypermetropia, convex lens. Myopia, 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 concave lens, myopia, concave lens. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole, distance are positive along the instant rays. Distance are negative, opposite to instant rays. Distance are positive, above the principal axis. Distance are negative, below the principal axis. Cartesian sign convention, Cartesian sign convention, Cartesian sign convention, Cartesian sign convention. Today we are going to discuss about. Today I am going to discuss about light reflection and refraction. 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 CBSE Grade 10 Physics. CBSE Grade 10 Physics. CBSE Grade 10 Physics. So I am considering plane mirror, plane mirror, plane mirror, plane mirror, plane mirror. So plane mirror, plane mirror, plane mirror. Everybody listen. Here I am going to teach reflection phenomena. Reflection phenomena. Reflection phenomena. Reflection phenomena. Reflection phenomena. I am considering the plane mirror. Plane mirror. Incident light rays, reflected light ray, incident ray, reflected ray, normal line, normal line, normal line, normal line, normal line. This the incident ray, reflected ray, normal line, normal line, normal line, normal line, normal line, normal line, perpendicular to plane mirror. I am considering the undeviated line. Undeviated line, the angle between incident and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Angle between incident and normal line is called angle between incident and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. And you are considering the angle between reflected and the undeviated line, undeviated line, undeviated line, undeviated line, undeviated line is called angle of deviation. Angle of deviation. Angle of deviation. The angle between incident and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Angle of reflection. Angle between reflected and deviated line. Undeviated line is called angle of deviation. Angle of deviation. Now I am considering here linear angle is 180 degrees. Linear angle is 180 degrees. Linear angle is 180 degrees. We know laws of reflection, laws of reflection, laws of reflection. loss of reflection, 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 loss, reflection of loss of reflection, incident ray, reflected ray, normal line, lies on the same plane, lies on the same plane. Incident ray, reflected ray, normal line, lies on the same plane. Second one, angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. These are laws 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 of reflection. Now you are considering in the so linear angle, linear angle, linear angle, linear angle, linear angle. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So here I am considering from laws of reflection, from laws of reflection, from laws of reflection, angle of reflection equal to angle of incidence. Angle of reflection equal to angle of incidence, that is nothing but angle of deviation equal to angle of deviation, angle of deviation equal to 180 minus 2 angle of incidence, angle of deviation equal to 180 minus 2 angle of incidence. So in the place of angle of incidence, can I substitute angle of reflection? Then what value we will get? Now you can see here, you can observe angle of deviation, angle of reflection, angle of reflection, angle of deviation, angle of reflection, angle of reflection, angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of reflection. Oh, angle of deviation equal to angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. From laws of reflection we can write in this way. From laws of reflection, laws of reflection, laws of reflection. From laws of reflection we can write like this. We can write like this. Now next topic is regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular reflection, irregular reflection. Where regular reflection takes place, when you are taking the smooth surface, incident light rays are parallel, reflected light rays also parallel to each other, incident light rays are parallel to each other, reflected light rays are also parallel to each other. That type of reflection is called regular reflection, regular reflection, regular reflection. Come on, regular reflection, regular reflection, regular reflection, regular reflection, regular reflection, regular reflection. Plane mirror, plane mirror, plane mirror. Highly polished smooth surface is called plane mirror. Plane mirror, plane mirror, plane mirror. Highly polished smooth surface is called plane mirror. Plane mirror. Highly polished smooth surface is called plane mirror. Plane mirror. Highly polished smooth surface is called Plane mirror, plane mirror. I am taking the plane mirror here. You can consider. Plane mirror, plane mirror, plane mirror. Incident light rays are parallel to each other. Incident light rays are parallel to each other. Incident light rays are parallel to each other. Reflected light rays are also parallel to each other. Reflected light rays are also parallel to each other. This type of reflection is called regular reflection. Regular reflection, regular reflection, regular reflection. Regular reflection, regular reflection, regular reflection, regular reflection. Incident light rays are parallel to each other. Then reflected light rays are also parallel to each other. Reflected light rays are also parallel to each other. This type of reflection is called regular reflection. Regular reflection takes place on smooth surface, on smooth surface, on smooth surface, on still water, on still water. Regular reflection takes place on smooth surface and still water, still water. Yes or no? Regular reflection, 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 regular reflection. Incident beam, incident beam, incident beam, incident beam. So this is a reflected beam, reflected beam, reflected beam, reflected beam. So irregular reflection, irregular reflection, irregular reflection. I am taking here. This is rough surface, rough surface, rough surface, rough surface, rough surface. Regular reflection, irregular reflection. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface, rough surface, rough surface, rough surface. Irregular reflection takes place on rough surface. This is irregular reflection. Irregular rough surface. I'm taking incident ray. Incident ray, incident ray, incident ray. Here incident light rays are parallel to each other. Incident light rays are parallel to each other. Reflected light rays are not parallel to each other. Reflected light rays are not parallel to each other. This type of reflection is called irregular reflection, irregular reflection, irregular reflection, irregular reflection, irregular reflection. So regular reflection takes place on smooth surface and still water. Irregular reflection takes place. Irregular reflection takes place on rough surface, rough surface, rough surface, rough surface. Smooth surface and rough surface. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Now you can go to the next one, next one, next one. A wall reflect the light rays and also a plane mirror reflect the light rays. So what is the difference between in the terms of reflection? Reflection, reflection. If on wall, on wall, on wall, on wall, and wall, and wall. Irregular reflection takes place on wall. Irregular reflection takes place on plane mirror, on plane mirror, on plane mirror, plane mirror, plane mirror, plane mirror, plane mirror, plane mirror. On plane mirror, we will get regular reflection. On plane mirror, we'll get regular reflection. On wall, you'll get irregular reflection, irregular reflection, irregular reflection, irregular reflection, irregular reflection. On wall, you will get. On wall, irregular reflection takes place. On plane mirror, regular reflection takes place. On plane mirror, irregular reflection takes place. On plane mirror, wall, irregular reflection. On wall, irregular reflection. On plane mirror, regular reflection. Regular reflection. Is it clear? Next one. Next one. Next one, we are going to the one more topic. That is observed object and image, 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 object and image. I'm taking the plane mirror here. That's the plane mirror. This is the plane mirror. This is the plane mirror. I'm taking here. So this is the real object, from that light rays are coming from the real object. So light rays are coming. So I'm taking these two light rays. I'm taking one light ray and one more light ray I'm taking here. So after reflection, those light rays are moving away. Those light rays are moving away. Those light rays are moving away. So if you are extending those light rays, extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. So this is a real object, and virtual image, real object and virtual image. This is the incident ray I1, R1, incident ray 2, I2, R2. These are the extended reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming. That image is called virtual image. I'm taking one more mirror. So this is the here light rays are coming from infinity. After reflection, all light rays are meeting at one point. After reflection, light rays are meeting at one point. That is called real image. So we are extending the incident light rays. Incident light rays are meeting at one point. That is called virtual object. Virtual object. Here I am taking this the from that point the light rays are coming. After reflection, the light rays are moving away from the principal axis. If you are extending those light rays, extending the reflected light rays are meeting at one point. Their image is forming. That is a virtual image. So these reflector light rays are meeting directly. Reflector light rays are meeting at one point. Their image is forming. That is real image. If directly reflector light rays are meeting at one point, directly reflector light rays are meeting at one point. Their image is forming. That is a real image. So if we are extending this extending of incident light rays, there those light rays will meet at one point on the principal axis. There the object, that is a virtual object. Tan 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 virtual object tan 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 virtual object very virtual object will form. If you are extending the incident light rays are meeting at one point. Their image is forming. Extended incident light rays. Are meeting at one point. There, that object is called virtual object. Virtual object. Okay, so here, if the reflector light rays are meeting, these are the reflector light ray R1, R2. Those reflector light rays are meeting at one point. Their image is forming. That is virtual image. Virtual image. Here you can see here So this is a reflector light ray, this is reflector light ray, reflected ray 1, reflected ray 2. If you are extending those reflector light rays, reflector light rays are meeting at one point. Extended reflector light rays. Here, this is reflected ray, this is reflector ray. We are extending those reflector light rays. Extended reflector light rays are meeting at one point. Their image is forming. That is virtual image. Virtual image, virtual image, virtual image, virtual image, virtual image, virtual image, virtual image. Here we are extending the reflector light rays. We are extending the reflector light rays. Reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Here directly reflector light rays are meeting. Directly reflector light rays are meeting. Directly reflector light rays are meeting. Their image is forming. That is a real image. That is a real image. That is a real image. Real image. Real image. Real image. Real image. Real image. Here we are extending the incident light rays. Extending the incident light rays. Extended incident light rays are meeting at one point. Extended incident light rays are meeting at one point. Their image will form. Where their image is formed, their light rays are meeting. That is virtual object. Virtual object. That's not image. Virtual object. Here extended incident light rays. Extended incident light rays are meeting. Their virtual object will form. Virtual object will. Virtual object. Virtual object. Virtual object. Virtual object. So now you can understand one thing. So you can once observe these two diagrams. Observe to these two diagrams and listen carefully what I am saying. Listen carefully what I am saying. I am saying if the object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. Very, very, very important points. Are you observing the diagram? Why I am doing all these things? Because those points are very, very important. Those points are very, very important. Those points are very, very important. Very, very important. Yes or no? Object is a real, image is virtual. Object is virtual, image is real. Vice versa. Vice versa. Object is real, image is virtual. Object is virtual, image is real. That's enough. Now I will draw in the tabular form. You can observe here. So I'm taking here object and image. Object is virtual, image is real. Object is real, image is virtual. Yes or no? Virtual, virtual, virtual. Dun, 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 dun. Virtual, 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 virtual. Virtual. Object is virtual, image is real. Object is real, image is virtual. Now I will show you how it is. So here you can see this is what is this image? Virtual image. What is this image? Real image. What is this one? Real object. What is this one? Virtual object. Now you observe real object, virtual image. Real object, virtual image. Real image, virtual object. Real image, virtual object. Yes or no? Yes or no? Yes or no? Yes or no? Let me know. Yes. So now, yes only. There is no option because concept is correct only. So then we can go to the next one. So image formation by formation of the image by formation of the image by or nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. 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 Plane mirror, plane mirror, plane mirror, plane mirror, mirror, plane mirror. Highly polished smooth surface is called plane mirror. Highly polished smooth surface is called plane mirror. Highly polished smooth surface is called plane mirror, plane mirror, plane mirror. Plane mirror. So I'm considering here. So I am taking object size. I'm taking this object AB. AB. So how many letters are required to form the image of the object? Come on, everybody say. How many letters are required to form the image of the object? How many letters are required to form the image of the object? Come on, everybody answer to the question. How many letters are required to form the image of the object? How many letters are required to form the image of the object? Minimum. How many letters are required to form the image of the object? Minimum 2 letters. Minimum 2 letters are required to form the image of the object. Minimum 2 letters are required to form the image of the object. So one letter I am taking here. Do you know one thing? That is, well, when light ray passes along the normal line, when light ray passes along the normal line, it reflects back into the same path. Along the normal line, reflect back into the same path. Now you see, so if you are taking this the incident ray, so it reflect back into the same path. So however it comes, in the same way it goes up. Yes or no? Yes. Like this. So here the same process will take place here. How many light rays? I said 2 light rays are required to form the image of the object. So minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. Image of the object. Dun. So I'm taking one more light ray. So it will be reflected back. So here along the light ray passing along the normal line, it retraces its original path. One more light ray I am taking, it will be reflected back. Here also I am taking here same way. I am considering here one more way and I am considering like this. Okay, so if you are extending those light rays, image will form. So I am considering here. Here. Dun, 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 dun. A dash, B dash, come on, A dash and B dash. A dash, B dash, A B, A dash, B dash. So now I am considering this one and this one. So I am considering here the distance between mirror to object is called object distance. The distance between mirror to object is called object distance. So the distance between mirror to image is called image distance. So here you can see the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Yes or no? So now you can see. So point number one. I already said this concept before. Are you understanding? Are you remembering? Are you listening or not? Are you focusing or not? That point is object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. Yes or no? Yes. So second point. What I'm saying, second point is object distance is equal to image distance. Object distance is equal to image distance. And in plane mirror only entire in all the mirrors, compared to all mirrors, only one, single one, super one, plane mirror, single one, super one, plane mirror. Image will form virtual erect and same size, virtual erect and same size. Magnification of the plane mirror is +1. Magnification of the mirror is +1 because height of the object is equal to height of the image. Because height of the object is equal to height of the image. Height of the object is equal to magnification is positive only in plane mirror. That is m equal to plus 1. Height of the object is equal to height of the image. Next one, last one, it also known as, it also shows lateral inversion. What is lateral inversion? Lateral inversion is the phenomenon of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. If I lift my right hand, so right hand, object right side, right hand, it appears in the mirror left side. Mirror, in the mirror, so image left side. If I lift my right hand in the mirror, it appears I am lifting left hand. If I lift my left hand, so in the mirror, it appears right side. This mirror image is called lateral inversion. Do you observe? Do you observe on the ambulance? They will write ambulance word in the mirror image format. When you see in the mirror, it appears proper. It appears proper. That is the example for mirror image. And I will ask one question. The question is, can I ask one question? Will you say the answer? The question is from A to Z. From A to Z, which letter does not show lateral inversion? From A to Z, which letter does not show lateral inversion? I will say no. I will say from my end. I will start. O letter does not show lateral inversion. Capital letters only. Which letter does not show lateral inversion? I am saying O. O does not show lateral inversion. Yes or no? O letter. O does not show lateral inversion. Remaining letters you can tell. Next one. I'm going to the one more. So in plane mirror, object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. Object distance is equal to image distance. In the plane mirror only. In the plane mirror. Virtual erect and same size. M equal to plus 1. And one more thing. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. And also it shows the lateral inversion. Lateral inversion. Okay, next one we are going to learn about spherical mirrors. Spherical mirrors. There are two types of spherical mirrors are there depending on reflection of light. There are two types of spherical mirrors. Are there. One is concave mirror, another one is convex mirror. Another one is convex mirror. Come on, everybody, look at the board. Ready? Are you ready for the witness of? Wow, just a miss. So that is closed circle. Okay, so I'm drawing like this. If you are considering this is a part of the sphere, so it is a part of the sphere. This is the part of the sphere. This is the part of the sphere I'm considering. Part of the sphere. Part of the sphere I'm considering. That is a concave mirror. Concave mirror. Concave mirror I'm considering. Concave mirror. Concave mirror. Concave mirror. Concave mirror. Concave mirror. Reflection takes place inward. Convex mirror. Reflection takes place outward. So here I'm considering I'm considering. So this is a concave mirror. When light ray incident on it, the light rays will reflect back and meet on the principal axis. So after reflection, light rays are moving towards the principal axis. After reflection, light rays are moving towards the principal axis. That's why it is called concave mirror. Concave mirror is also known as converging mirror. Concave mirror is known as converging mirror. Converging mirror, converging mirror. Convex mirror is also known as diverging mirror. Convex mirror is also known as convex mirror is also known as diverging mirror. Diverging mirror. Convex mirror is also known as diverging mirror. When light rays are incidenting on it, will be reflected back. If you are considering here, after reflection, those light rays will move away from the principal axis. Are you understanding one thing? Here? When light rays are incidenting on it, if the light rays are incidenting on it after reflection, light rays will move towards the principal axis. That is called concave mirror. That mirror is also known as converging mirror. Converging mirror. Convex mirror is also known as diverging mirror. Why? What is the reason? What is the reason why convex mirror is also known as diverging mirror? Because after incidenting, after reflection, the light rays will move away from the principal axis. After reflection, light rays will move away from the principal axis. This is the principal axis. After reflection, light rays are moving away from the principal axis. That's why convex mirror is also known as diverging mirror. Diverging mirror. Diverging mirror. Diverging mirror, diverging mirror, diverging mirror, diverging mirror, diverging mirror, diverging mirror. Concave mirror is converging mirror. Convex mirror is diverging mirror. Diverging mirror. Concave is converging, convex is diverging. Yes or no? Next one. Rare rules of concave mirror. No. We have to discuss terms related to concave mirror. We have to discuss about terms related to concave mirror. How can you discuss? So directly you are going to the ray rules. So how it is possible? How can you go like that? We have to discuss terms related to spherical mirror. Yes, we have to discuss terms related to spherical mirror. We should not go to the ray rules. Yes or no? We should not go to the ray rules. First we have to discuss terms related to spherical mirror. We have to discuss. After that we have to go to the ray rules of concave mirror and convex mirror. Shall we discuss terms related to spherical mirror? Are you ready? Yes or no? Come to the point. So I'm taking the plane mirror, like no. Concave mirror, spherical mirror, the mirror which is the form of curved shape. The mirror which is in the form of curved shape. The mirror which is in the form of curved shape is called spherical mirror. Spherical mirror. There are two types of spherical mirrors are there. Do you know? There are two types of spherical mirror. Just now I said to you, right? Those are concave mirror and convex mirror. Concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. Diverging mirror. Yes or no? Now you are taking here. This is a part of the sphere. This is a part of the sphere. This is a part of the sphere. The center of the imaginary sphere. The center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. Line joining of center of curvature and pole is called line joining of center of curvature and pole is called principal axis. Principal axis. Principal axis, 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 principal axis. Yes or no? Principal axis. Now, so first point is center of curvature, second point is pole, third point is principal axis. Principal axis. Principal axis. The distance between center of curvature and pole is called distance between center of curvature and pole is called radius of curvature. Radius of curvature. Distance between center of curvature and pole is called radius of curvature. Radius of curvature. Radius of curvature. The distance between center of curvature and pole. Distance between center of curvature and pole is called radius of curvature. Radius of curvature. Fifth one. After reflection, light rays are moving at one point on the principal axis. After reflection, light rays are moving at one point on the principal axis. After reflection, light rays are moving at one point on the principal axis is called principal focus. Principal focus. Simple way we can call focus. Are you focusing? Focus? Yes or no? Let me know. So the distance between focus to pole is called focal length. Come on, focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. 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 Next one, seventh one, aperture. 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 The reflecting surface is called aperture. Reflecting surface is called aperture. Reflecting surface or where the reflecting surface means this one. The diameter of the reflecting surface is called aperture. Aperture. Yes or no? Aperture. Now we are going to discuss about center of curvature, center of the imaginary sphere in which mirror is a part. First one, center of the imaginary sphere in which mirror is a part is called center of curvature. Midpoint of the mirror is called pole. So the line joining of center of curvature and pole is called principal axis. The distance between center of curvature and pole is called radius of curvature. Distance between center of curvature and pole is called radius of curvature. After reflection, all light rays are meeting at one point on the principal axis called focus. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The width of the mirror reflecting surface is called aperture. 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 Yes or no? Now Concave mirror, concave mirror, convex mirror. So first one I'm taking concave mirror. So pole focus, center of curvature. After reflection, light ray will pass through the focus. Light ray is coming from infinity. After reflection, passes through focus. So if the light ray passing through center of curvature, it retraces its original path. If the light ray passing through center of curvature, it retraces its original path. Fourth one. So pole, focus, center of curvature, light ray incident. If the light ray incident at the pole, it reflect back. So next one is convex mirror. So here you can observe one thing. So light ray is parallel to the principal axis. After reflection passes through the focus. Light ray passing through the focus after reflection moves towards infinity. Light ray passing through center curvature, it retraces its original path. So light ray incident the pole, it reflect back. So it's the same way in convex mirror. Convex mirror. Come on. First one. Convex mirror I'm taking. Convex mirror. Diverging mirror. Concave mirror. Converging mirror. Concave mirror. Converging mirror. Converging mirror. Light ray is coming from infinity. After reflection. Second one. Light ray is coming from. It passes through focus. After that, third one. Everybody be ready. Dun 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 dun. So after that, after that, passes through center of curvature. The last one, the final one, the ultimate one, that is like a reflection. Like a reflection. Dun, 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 dun. So I'm taking your considering this is pole, focus, center of curvature. Dun 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 dun. This is the incident ray. Then it is coming out. So that is reflected ray, like this. Pole. When the light ray incident at the pole, it reflects back. The concave mirror. converging mirror, convex mirror, diverging mirror, concave mirror, converging mirror, convex mirror is diverging mirror, diverging mirror, concave mirror is converging mirror, convex mirror is diverging mirror, diverging mirror. Why we are calling concave mirror is converging mirror? After reflection, light rays will move towards the principal axis, whereas convex mirror after reflection light rays will move away from the principal axis. Principal axis. Dun, 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 dun. Dun, 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 dun. Yes or no? Yes or no? So this is about concave mirror and convex mirror, concave mirror and concave mirror and convex mirror, concave mirror and convex mirror. So I hope so you are clear with that. So next one we are going to discuss about image formations, image formations of concave mirror, image formations of concave mirror. Concave mirror, image formations. Ready, concave mirror, image formations, concave mirror, image formation. First one. So I'm taking the concave mirror here. Concave mirror I'm considering here. So this is the pole, focus, center of curvature. So concave mirror, concave mirror, concave mirror. Object is at infinity. Light rays are coming like this. After reflection, light rays will meet at one point on the principal axis. So image will form at focus. So object is at infinity. Object is at infinity. Image will form at object is at infinity. Image will form at focus. Nature of the image is real and inverted. Size of the image is highly diminished. Coming to the second one. Coming to the second one. So I'm taking the concave mirror, concave mirror, concave mirror, concave mirror. Pole focus, pole focus, center of curvature. Object is placed beyond center of curvature. Object is placed beyond center of curvature. Object is placed beyond center of curvature. One light I am taking like this. After that passes through focus. Another light I am taking passes through center of curvature. So after that it reflects back. Where image will form? Where image will form? The image will form between C and F. Image will form between C and F. Image will form between C and F. C and object is placed beyond center of curvature. Object is placed beyond center of curvature. Image will form between C and F. Nature of the image is real and inverted. Size of the image is diminished. 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 Coming to the third one. Coming to the third one. Third one you can see. Third one. So object I am taking at center of curvature. One light I am taking like this. Object at C. Image also will form at C. Nature of the image is real and inverted. Size of the image is same size. Size of the image is same size. Coming to the fourth one. Coming to the next one. Next one. So pole, focus, center of curvature. Object is placed between C and F. Object is placed between C and F. One light I am taking like this. After that it passes through focus. Another light I am meeting at a pole. Object between C and F. Image will form beyond C. Nature of the image is real and inverted. Size of the image is L large compared to the object. Compared to the object, image size is increased. Compared to object, image size is increased. Coming to the fifth one. So pole, focus, center of curvature, object is placed at F. Object is placed at F. Image will form at infinity. So object is placed at F. One light I am taking like this. Another light I am taking here. So object is at F. Image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Highly enlarged. Last one, sixth case, very, 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 very important. So in a movie, how the hero, how much important. So how it is for movie. How much importance for movie. So how he will play a extraordinary role to cover all the accepts. Here also same thing. Here also same thing. Here also same thing. So entire, if you prepare everything, if you prepare all the diagrams, they will give in the exam this one. They will give this one in the exam. That is power of sixth case in concave mirror. Power of sixth case in exam hall. Yes or no? Very, very, very important. Ready? Be ready. Are you ready? I'm taking the concave mirror. So this is the pole, focus, center of curvature. So I'm placing the object here. So and one more thing I'm taking here. If you are extending this light rays, object is between F and P. Image will form behind the mirror. Nature of the image is virtual, erect and enlarged. So this is about plane mirror. Once observe the diagrams. Okay, so we'll see the next convex mirror image formations. So everybody observe. So once check this one. I will explain the 10:30. Okay, so come on, next one. Convex mirror. Convex mirror. Convex mirror. Convex mirror. Convex mirror. Convex mirror, convex mirror, convex mirror. So in convex mirror, only two image formations. Only two image formation. First one I'm taking. This is a convex mirror. How many images are there? Only two image formations. Pole, focus, center of curvature. Object is placed at infinity. How many light rays are required to form the image of the object? Minimal light rays are. How many? Two light rays are required to form the image of the object. I'm taking one light ray, another light ray after reflection. We are extending those light rays. We are extending those light rays. Those light rays are meeting at one point. Object is at infinity. Image is forming at focus. Nature of the image is virtual erect. Virtual erect. Virtual erect. Virtual erect. Object is at infinity. Image is forming at focus. Nature of the image virtual erect and highly diminished. Coming to the second one. Second one. So I'm considering here. Pole, focus, center of curvature. One light ray. Object is placed anywhere between P and infinity. Image will form between P and F. P and F, P and F, P and F, P and F. Dun, 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 dun. How many light rays are required to form the image of the object? Minimum two light rays are required to form the image of the object. Yes or no? Yes. So I'm taking here, considering reflector light rays. So image will form between. So this is pole, focus, center, curvature. Image will form between P and F. Image will form between P and F. So nature of the image is virtual erect and nature of the image is virtual erect and nature of the image virtual erect and diminished. Virtual erect and diminished. Okay. Nature of the image is virtual erect. Size of the image is diminished. So this is about convex mirror. Mirror. 1 by F equal to 1 by V plus 1 by U. So this is the mirror formula. M equal to minus V by U. That is nothing but height of the image by height of the object. So this is about mirror formula and magnification, mirror formula and magnification. Next one we will discuss about convex. So we can go with the refraction phenomena. Refraction phenomena. Refraction is when the light ray is passing from, so here I am considering this is the plane. I am taking the rarer medium and denser medium. Okay. So two different medium. If I am taking this is the air I am considering this is water, air and water. If the light ray is passing from rarer to denser, if the light ray is passing from rarer to denser, at the point of interference, the light ray will bend. At the point of interference, the light ray will bend. The angle between incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. Angle between incident ray and normal line is called angle between incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. So here, if the light ray is passing from denser medium to rarer medium, this is the example for refraction when light ray is moving from rarer to denser at the point of interference between two media, light ray will bend towards the normal line. So if it is passing from rarer to denser, it bends towards the normal line. So in the same case, if the light ray passing from denser to rarer, what happens? If the light ray passing from denser to rarer, it moves away from the normal line. So the angle between incident and normal line is called angle of incident. Angle between refracted ray and normal line is called angle of refraction. Here, angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. If the light ray is moving from rarer to denser, bends towards the normal line. If the light ray is moving from denser to rarer, the light ray will move. The refracted ray will move away from the normal line. So coming to the laws of refraction. Laws of refraction are Snell's law. Laws of refraction, Snell's law. First one, incident ray, reflected ray, normal line lies in the same plane. Sine of angle of incidence to sine of angle of refraction equal to constant. Sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incidence to sine of angle of refraction equal to constant. That is nothing but n. I am taking n. Yes or no? So this is the if you are taking sine of angle of incident to sine of angle of refraction equal to constant, that is refractive index. So absolute refractive index is nothing but C by V. The ratio of speed of light in vacuum by speed of light in medium. Is called absolute refractive index. Relative refractive index. So I am taking here N2 by N1 is equal to V1 by V2. N12, if you are taking N1 by N2 is equal to V2 by V1. So this is about the refractive index. Very important. Refractive index is very important. Definitely one mark question will come. So in the exam, this concept is very important. Absolute refractive index N equal to C by V. So speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium is called absolute refractive index. Relative refractive index is nothing but speed of light in medium 1 by speed of light in medium 2. Speed of light in medium 1 by speed of light in medium 2 is called relative refractive index. So this can be. This one we can also write in this way. So either this one or 2 1. So any one format we can write. In the exam they will ask. So if they ask questions in that format, so refractive index of glass with respect to water. So how we have to write? What are the medium comes first? that you have to mention. Refractive index of glass with respect to water. Refractive index of water with respect to glass. Refractive index of air with respect to water. Refractive index of air with respect to glass. Refractive index of glass with respect to water, or refractive index of water with respect to glass, like that. Okay, so what are the medium comes first with respect to, after that, so after with respect, then if you are taking medium 1, medium 2, so after this one we have to write next. So whatever the medium comes first, whatever the medium comes first, that you have to write first. So N1, 2. Refractive index of medium with respect to medium 2. Refractive index of medium 1 with respect to medium 2. So first whatever the medium comes first, that you have to write. That you have to write. Later next medium. Later next medium. So you can check any problem. You can check any problem. I am telling to you. You can check any problem. Any book you can check. Whatever the medium is coming first, that you have to write. Later next medium. So refractive index of medium 1 with respect to medium 2. Refractive index of glass with respect to water. Refractive index of water with respect to air. Refractive index of air with respect to glass. Refractive index of air with respect to water. Whatever the medium is coming first, you have to write first. Next with respect to that, after the second medium you have to write second later. So here refractive index of water with respect to glass, refractive index of medium with respect to second medium. Whatever the medium is coming first, you have to write. Check in any book and let me know. Yes or no? So we are going to the next one. We are going to the next one. So next one. So next one. Here you can see glass slab. So light ray is incidenting on it. So if you are drawing the normal line, so it will be refracted. Again, if you are passing like this is emergent ray, and I am considering this the initial direction of the incident direction of the incident ray. So if you are taking angle between incident ray, normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. So the angle between, so the distance between emergent ray and initial direction of the incident ray is called lateral shift. Lateral shift. So this is called lateral shift. Lateral shift. Okay. So next one, we'll discuss about lens image formation, and ray rules. Lens image formations and ray rules we'll discuss now. Lens image formations and ray rules. Now you can see ray rules, only 3 ray rules are there. Convex ray rules. Ray rules for convex lens. So I'm taking the convex lens here. So optic center. So optic center F1, 2F1, F2, 2F2. If the light ray is coming parallel to the principal axis after refraction passes through focus, first one coming to the second one, light ray is passing through the focus, optic center F1, 2F1, F2, 2F2. If the light ray is passing through the focus, After refraction, passes parallel to the principal axis. Third one, so optic center F1, 2F1, F2, 2F2. Light ray is passing through optic center. Light ray is passing through optic center. No deviation. It passes like that only. So undeviated line. Coming to the convex, concave. This is the convex lens. Convex lens. Next concave lens. Concave lens. So pole optic center F1, 2F1, F2, 2F2. Light ray is parallel to the principal axis. Light ray is parallel to the principal axis. After refraction, it diverge. Second one, optic center F1, 2F1, F2, 2F2. Light ray is passing through the focus. After refraction, become parallel to the principal axis. Third one, optic center F1, 2F1, F2, 2F2. Light ray passes through optic center, no deviation. It will be undeviated line. Undeviated line. Okay, so like this. Next one we are going for image formations of convex and concave lens. So convex lens image formations. So I'm considering here optic center F1, 2F1, F2, 2F2. Object is at infinity, image is forming at F2. How many light rays are required to form the image of the object? Minimum 2 light rays. So that's why I'm taking one light ray. Another light ray after refraction passes through focus. So object is image will form at F2. Nature of the image is real and inverted and highly diminished. Second one, optic center F1, 2F1, F2, 2F2. Object is placed beyond 2F1. Object is placed beyond 2F1. So image will form between F2 and 2F2. Object is placed beyond 2F1. Image will form between F2 and 2F2. Nature of the image real and inverted. Size of the image diminished. Object is 2f1. Image will form at 2f2. Nature of the image real and inverted. Size of the image same size. Same size. Coming to fourth one. Object is placed between 2f1 and f1. One light I am taking passes through focus. Object is between 2f1 and f1. Image will form beyond 2f2. Beyond 2f2. Nature of the image is real and inverted. And enlarged. Size of the image is enlarged. Fifth one. Optic center. f1. 2f1. f2. 2f2. So object is placed at f1. Object is f1. Image will form at infinity. Nature of the image is real and inverted, highly enlarged. So last case is very very important. Last case is very very important. So check once. Last case. So if we are extending this light rays will meet so image will form here. Image will form. Object is placed between f1 and O. Image will form same side of the object. Same side of the object. Nature of the image virtual erect and enlarged. Okay, so this diagram is very very important. So make sure that you are practicing. So very very important. Check once. Convex lens image formation. Then we'll discuss about concave lens image formation. Next one we are going to discuss about concave lens image formation. So now concave lens image formations. Concave lens image formation. Concave lens image formation. So concave lens, only two image formations are there. Concave lens, only two image formations. We'll discuss only those. So check it once. You can check once. Concave lens image formations. So optic center F1, 2F1, F2, 2F2. So object is placed at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So that's why I'm taking here. So if you are taking extension, those will meet here. So image will form at F1. Nature of the image is virtual, erect and diminished, highly diminished, because point size image will form. Next one, second case. Second case. So I'm taking optic center F1, 2F1, F2, 2F2. Object is placed between anywhere between pole and infinity. Object is placed between anywhere. Object is placed anywhere between pole and infinity. Pole and infinity. I'm taking here. One light I'm taking like this, it passes. Another light it passes through optic center. The image will form. Image, as I said, object is between pole and infinity. Image will form. Image will form between F and O. Nature of the image is virtual, erect, and diminished. Virtual, erect, and diminished. So these are very, very important. These two diagrams: concave lens, concave lens, concave lens, concave lens. Okay. So next one. So power of lens is positive for convex. Power of lens is negative for concave lens. Power is positive for concave lens. Sorry, convex lens. Power is positive for convex lens. Power is negative for concave lens. Negative for concave lens. Power is positive for convex lens. Power is negative for concave lens. P is nothing but power. Power of lens. Power of convex lens is positive. Power of concave lens is negative. P equal to 1 by F. Reciprocal of focal length. P equal to 1 by F. Reciprocal of focal length. The degree of converging or diverging of lengths achieved. The degree of converging or diverging of lengths achieved is known as power of lens. Power of lens. P equal to 1 by F. P equal to 1 by F. Okay. So that's enough. That is about topic. So I hope we completed entire topic. So if you have any doubts, you can ask. So we can discuss. Okay. So thank you so much for joining and attending and involving and interacting with me. Thank you so much. Thank you for listening the class. Thank you so much. We'll see in the next class with a new topic. Thank you so much. See you. Signing off.